Hello everyone, this is Vineet from Edureka. In today's session we are going to focus on MapReduce examples. Let's move on and look at today's agenda. The very first thing that we'll do is we'll revise the MapReduce way that we learned in our previous sessions. Going on, we'll explore the classes and packages that are available in MapReduce using which one can write a MapReduce program. I'll be explaining you the various components of a MapReduce program like the mapper, the reducer and the MapReduce driver. Okay. We'll be looking at MapReduce examples on analytics, and we will also explore MapReduce examples on testing. Okay. Guys, are you clear with today's agenda? If you can write down on the chat window, that would be great. Omar says yes, Matt says yes, Himanshu says yes, Jessica says yes. Himanshu says how many practicals are there? Himanshu, don't you worry, the entire session is based on practicals. Okay, so you'll have at least 2-3 practicals for today's session. Does that sound interesting, guys? Himanshu says great. So let's move on, and we start off with MapReduce example on word count. We already saw this example in our previous session. However, let's refresh this so that we do not miss out on anything. As you saw, we had input file which was divided into input splits. These splits were passed on to the map functions. The output of the map functions was passed on to reduced functions, and an aggregation task was performed at the reducer. Finally, the complete output was sent back to the client. Okay. Now this was the example that we looked at. The entire input was deer, bear, river, car, river, deer, car, bear. We had 3 input splits, deer, bear, river, that is 1, car, river, that is 2nd, the third one was deer, car, bear. There was a mapping phase in which the count of 1 was assigned against every word that was there in the input split. So deer, 1, bear, 1, river, 1. Similarly for input split 2 and for input split 3. In the shuffling phase, all the keys had a list of values that was assigned by going through all the results that was given out by the mapping function. Similarly, so for beer it was 1, 1 because beer 1 and then another beer 1 was there in the third split. Similarly happened for car, so it became car, 1, 1, 1. The same happened for deer, that is deer 1, 1, and finally happened for river, that is river 1, 1. In the reducing phase, for every key, the list of values were summed up and the result was beer, 2, car, 3, deer, 2, river, 2. And finally, this was the final output on the right, which was sent back to the client. So this was the word count process using MapReduce. Guys, I hope you can clearly recall what we learned in the last session before we move on. Can you give me a quick confirmation? Omar says yes. Himanshu says yes. Jessica says yes. What about Matt? Matt says okay. Let's move on then. Guys, before we move on and explore the input and output classes in MapReduce, I wanted to tell you that the input data set that you push into your mapper functions or the output that is given out by the MapReduce program altogether can only be in certain formats. Now these formats are nothing but the data types, like you had int in Java. Okay, you had string in Java. Similarly, you have certain data types that are available in MapReduce. In these formats only, MapReduce can accept the input or can give the output finally. Okay, so let's explore the classes that are available. First, we'll go through the input format. Now we have an input format which is a superclass which is present in the package org-apache.hadoop.mapreduce. We have 3 different types of input formats within input format. That is the superclass. We have file input format, we have composable input format, and then finally we have DB input format. Okay, file input format is the most commonly used input format that is there, which has a list of input formats under it. That is like combined file input format, text input format, key value text input format, n-line input format, sequence file input format. Sequence file input format is something which takes sequence files as an input. N-line input format takes n number of lines as an input altogether. Text input format takes one singular line which is in text form, right? Similarly, we have composable input format which can be used, and then finally a DB input format. So guys, please don't worry about this right now. I'm going to take up certain examples in which I'll be using one of these input formats, which will give you a better perspective how to use them. Okay, are you clear? Good. Thanks, Omar. So Umar says, can't we have custom input format? Absolutely, Umar, you can also have custom input format. However, we are not going to discuss that in today's session. It is because first we need to understand how to use a normal input format and then finally write a MapReduce program. Okay, once we are done with that, in our later sessions, we can certainly go through this topic as well. Is it clear? So we have a question from Matt, and he says, according to the diagram, file input format and composable input format has two attributes as input, that is K and V, whereas DB input format has only one attribute, that is T. That is a very good question, Matt, and let me tell you at this moment, that is composable input format takes two attributes, which is nothing but the key and value. Okay, and this could be either of the data types that are supported by Hadoop, like int writable, long writable, and so on. Okay, whereas DB input format has only one attribute, which is of type DB writable, which is nothing but reading a data from a table from a database. Is it clear to you? So maths is okay? Great. Let's move on and explore the output formats that are available, which can be used in a MapReduce program. Now this is the superclass, that is output format, which is present in org apache hadoop.mapreduce package. Now there are basically four types of output formats. File output format, the most commonly used. Null output format, in which there is no output that has to be given. DB output format, which gives out DB writable kind of an object. Filter output format. Okay, that is the fourth one. File output format can be divided into two types, that is text output format, which basically dumps out the output as text. Second is the sequence file output format, and I'm sure you can clearly tell me what will be the output from sequence file output format. Can you please tell me? Omar says binary files. Absolutely, binary files are stored as sequence files. So guys, are you clear with the available output formats that are there? Can you give me a quick confirmation? Good. So let's move on and let's understand the packages and classes in a word count MapReduce example. In our previous session, we understood how to execute a MapReduce example that is present with the Hadoop package itself. However, in this session, I'll tell you how to write a MapReduce program of your own using Java, as well as I'll tell you what are the packages and classes that are required to do that. So the very first thing is to explore the classes that are used for writing a MapReduce program, right? Let's move on. Now the very first thing is the list of the packages that needs to be imported, which is there in the Hadoop jar file. Now these are the packages or libraries that needs to be imported from the Hadoop package so that we get the required classes for writing the MapReduce program. First we are importing the Java IO package and the util packages that are available in Java. Moving on, we import the packages that are available within the Hadoop commons.jar. Okay, so basically we are importing Hadoop fs path, we are importing hadoop.conf, and then Hadoop IO packages. Now all these packages are required. For example, input output is required for taking the input and giving out the output. So there are certain classes for that which needs to be used in the MapReduce program. Similarly, hadoop.conf defines the configuration of your Hadoop job. So fs.path enables you to access a path that is present in Hadoop file system, as well as create certain directories in the Hadoop file system or read from that, right? Moving on, we have another set of packages that needs to be imported, which are present in Hadoop MapReduce client core jar. Okay, now both these jars are available in your Hadoop package itself. Okay, so what we are doing is we are importing text output format, okay, which is a kind of output format. We are importing text input format that we saw in the input format list, right? So these are the list of packages that needs to be imported for writing a MapReduce program. Himanshu says, do we need all these packages in our MapReduce program? Absolutely yes. These are the list of packages which are a must that you will minimally require to write a MapReduce program. Okay? Is it clear, Himanshu? Okay. Maths is okay. What about you, Himanshu? Himanshu says, so there are more packages? Absolutely yes, Himanshu. As per the need, you need to import those packages. Okay? You can certainly go on and explore the jar file, and using that you'll be able to get to know what are the other packages that are available. Now in this class we are understanding we need to create a map class. Now in order to create the map class, we need to extend the super class, that is the mapper class defined in our Hadoop package. Now this mapper class takes 4 arguments as input and they are of certain types. So we need to define the types of the arguments. So the input key is long writable, the input value is text, the output key is text, and the output value is int writable. So guys, I hope you're clear with this. Omar says yes. What about the rest of you? Thank you very much, Himanshu. And the others, let's move on. Now we come on to the second important class that needs to be implemented in a MapReduce program, that is nothing but the reducer class. Now I'm defining a reducer class of the name reduce, which needs to extend the superclass that is reducer just like the mapper class, right? That we saw in our previous slide. Now this reducer class also takes 4 arguments as inputs, that is the input key, the input value, the output key, and the output value. Now we need to mention the types of these values. Now as you can see here, the input key for reducer is set to text, the input value is int writable, the output key is text, and the output value is int writable. Now this is how we are declaring the reducer class. So guys, are you clear with this? Matt has a question. So does the output from mapper goes into reducer? Absolutely yes, Matt. We'll understand this better when I'll explain you the entire word count example. Okay. Omar says the input output data types here has been set corresponding to the word count example. Is it so? Yes, Omar, you are absolutely right. Okay. So guys, I hope you are clear with 2 important classes that needs to be declared and how they needs to be declared for writing a MapReduce program. In this case, it is word count. So let's move on. So it's time to see some MapReduce example. To start with, let me take you through the word count example itself. Okay. So it's time for some practical, guys. So it's time for some practicals. I'll take you to the Edureka VM now. So this is Eclipse, guys. This is the IDE for writing a Java MapReduce program. So the very first thing is you need to create a Java project. So you can go to new, click on project, select the type of project that you want to create, and then click on next. Give the name of the project and then click on finish. Okay. So I have already created my projects. This is the word count project in which I have my word count.java file. Okay. So the very first thing that we saw in the presentation was we were importing certain packages from 2 jar files. Okay. So as you can see, I have added 2 jar files, that is Hadoop MapReduce client core and Hadoop common. Okay. These jar files can easily be found in the Hadoop package itself. Okay. And the path for these files are right here. That is user lib Hadoop 2.2.0 or the version that you have. Under that you have share folder, within that Hadoop, and then within that MapReduce. You'll find this jar file there. Similarly, you'll find commons jar under the common folder which is present in Hadoop and then which is present in share folder. Okay. How can you add it to the build path? Now build path is nothing but telling the MapReduce program where to find these jar files. Okay, so what you need to do is go to the build path, configure build path. Okay, go to libraries, click on add external jars. Now locate your jar files. I'll go to file system, user, lib, Hadoop. Now since my Hadoop was there in user lib, so I went there. Within this you need to go to share folder. Then you need to go to Hadoop folder. The very first jar, that is Hadoop MapReduce client jar, is present under MapReduce right here. This one. Okay. The second jar is present under common, and then this is the jar file. You click OK and this gets added right here, and then finally you click OK. Okay. So this is how you need to add both the jar files in your class path. Once you are done with that, you can come here and you can import all these packages right here. These are the same packages that we saw in the presentation. That is file output format, input format, text input format, text output format. We have got mapper, we have got reducer class, which is nothing but the super classes. Okay. So let's see the major classes that are present in this word count.java file. If we divide the entire program, we have got one main class that is called word count, which has got one class that is map and the second class that is reduce. Map is the class which extends the super class that is called mapper, which takes attributes that is long writable, text, text and int writable. Okay, so this is the input key, this is the input value, this is the output key, and this is the output value. Similarly, you have another class reduce, which extends the reducer class, the superclass, which takes 4 attributes. The input key is of text type, the input value is of int writable type, the output key will be of text type, and the output value would be of int writable type. Guys, are you clear with this? This is what we saw in the presentation. Okay, it's great. I'm getting a lot of yeses. Good. Omar says, why have we specified the input key data type as long writable? It is because the input key would be of long writable type. Okay, it would be a hexadecimal number, which is a long writable number. I'll be explaining it to you in a while. Okay. Now, if you see the output key value types of the mapper, is exactly the same as the input key value types of the reducer. Okay, can you see that, everyone? Umar says yes, Himanshu says yes. So guys, this is the answer to your question, that is the output of the mapper class is sent as an input to the reducer class, and that is why the types of key value pairs of the mapper output is exactly the same as the input key value types of the reducer. Is it clear, guys? Do you want me to explain again? Good. Now let's see what is written within the map class. Okay. So after you extend the mapper class, you need to implement the map function. This is the map function which will have the actual logic of your mapper. Okay. The input attributes are long writable key, text, and value. Okay. So we are giving the name of the variables, and this is the type of the data that can be stored within this variables. So this is exactly the same long writable, which is nothing but the input key of the mapper class. The text is the input value of the mapper class, correct? Now the last thing is the context. Now context is another class which is used to write the output of the mapper class. Okay. Now let's understand the logic which is present within the map function. In the very first line, we are converting the value that was passed into the mapper to string and storing within a variable that is called line, which is of type string. Okay. So let's take an example. Okay. Let's say the input text was, this is Edureka class 3. Okay. So the key here would be the byte offset of every line. So every line has got its own byte offset, which is nothing but a hexadecimal number. Okay, and that is why the input type of the key is long writable. Okay, so this answers another question that was asked in the session previously. Okay, so this would be the key. The entire line would go into the value, okay, which is, this is Edureka class 3. Okay, so which is nothing but of text type. So that is why what we are doing is we are converting this to string and storing within a variable that is called line. Okay, guys, are we clear till now? Good. Post that we'll be using a string tokenizer. Now this line variable will be passed to an object of string tokenizer class. Now string tokenizer is used to extract the words on the basis of spaces that are present between them. Okay. Now what I'm doing here is I'm creating this object tokenizer and I'm passing the variable line which contains the entire line. Okay, the value. Now once it is passed, we need to run a loop, an iterator, which is a while loop here. Now this particular statement is checking whether the tokenizer has got any more words or not. Till the time the tokenizer has got tokens or words within it, the while loop will keep on running. Okay. Now once we go within the while loop, what we are doing is we are using a variable value dot set. We are assigning a value to the variable value, and the value would be tokenizer.next token. What we are doing is we are picking up the next word that is present in the tokenizer and we are assigning it to the variable that is called value. Okay. After that, we are using the context object that was defined right here, and we are calling the function write. Within that, we need to pass two attributes. One is the key and the second is value. So the key right here is the word, okay, that we extracted from the tokenizer, and then we are assigning a value of 1 against it. If you recall the explanation that I gave you previously, we need to assign 1 against every word to find the word count, right? So what is going to happen is the very first value will be this, okay, and what will be written would be this comma 1. Similarly, the second value would be is, and what will be written from the mapper as output would be is comma 1. The third would be edureka, and the value that would be written out would be edureka comma 1. Similarly will happen for class, so it would be class comma 1 and then 3 comma 1. Once it is done, tokenizer.hasMoreTokens will return a false value and it will exit the while loop, and then finally the mapper would be finished. Guys, are you clear with the logic that is written right here? If you can give me a quick confirmation, and if you have any questions you can ask me right now. Omar says yes. Matt says yes. What about the rest of you? Himanshu says yes. Great. Just remember the output here. This one is 1, edureka 1, class 1 and 3 1. Now we'll move into the reducer implementation. Just like the mapper, we have a reducer class which extends the main class or the super class that is called reducer, and these are the attributes. So we have input key as text and input value as int writable, which is nothing but the output that was given by the mapper, right? The mapper output was of type text key and int writable value. Now the key value output from the reducer would be of type text and int writable respectively, right? Now as soon as you extend the reducer class, next thing is you need to implement the reduce function, okay? Now the reduce function will take 3 attributes as input: key text, second would be values which is of type iterable, which has values of type int writable, okay, and then finally the context. Context is, as you know, is used to write the final output from the reducer or the mapper, okay. Now we need to understand what is iterable here. Now iterable is nothing but the list of values. So if you recall, in the reducer phase the input is key and a list of values. So this is nothing but the list of values that are against a particular key. Guys, are you clear with this? So Omar has a question. He says, we are writing a Hadoop MapReduce program using Java, and Java happens to be the native language of with Hadoop. So why isn't we are using the same data types that are present in Java with Hadoop? Umar, this is because the data types that are there in Hadoop are specifically designed for a distributed file system, and then finally which can be used as an input format to a MapReduce program, okay. The generic data types that are there in Java is something which cannot be used right away, okay. So guys, I hope you are clear with the reduce function and the attributes that are passed to the reduce function. Now let's understand the logic that is there, the aggregation that is done in the reduce function. Okay, so first we are defining a variable that is called int sum equals to 0. This is nothing but to calculate the frequency of the key or the word. Okay, now we are running a for each loop. Okay, so we have values of int writable type. So we are defining a variable int writable x. We are passing on the iterable, that is values. Okay, so we'll read every value that is present within this iterable, okay, and we'll keep on adding this using this particular Java statement. Okay, so the very first value is read from values iterable and gets stored in x. It comes here and it gets added to sum. Then again the for loop is repeated. The second value comes into x, it comes here and it gets added to the previous value of sum. And this loop will keep on executing till it reaches the end of the values iterable. So once all the values are read from the values iterable, it exits the for loop. Finally what we are doing is we are writing down the key, which is nothing but the word, and the sum of the values that was received from the for function as the output from the reducer function, right? Now let's try and take up the same example that we were dealing while understanding the MapReduce function. So this was the output. So what we have here is, so this is what we should receive as an input. Okay, so this was there only once, so it will be 1 itself. Similarly, is, comma, 1 would be there, and similarly the rest of the will be there. Okay, so within the parenthesis actually explains that this is a list. Okay, this is what I am trying to signify there. Now let's say there was another is in the input file, so it would be is comma 1, right? So what will happen here is, instead of is comma 1 in the list, there would be another 1. So this is what is received as an input by the reducer. Guys, are you clear with this? Omar says yes. Great. Finally, let's come down and try and pass it from the for function. So for the very first value, that is this 1, what will happen is this comes here. So the very first key and list of values that will come as an input to this reducer would be this 1. The value that gets stored into sum would be 1. So list of values right here contains only 1. Okay, so the context output would be text comma 1. Similarly, is and this list would be passed to the reducer. The value of sum here would be, anybody would like to guess what will be the value of sum for key is? Absolutely right, everyone. It would be 2, because 1 plus 1 will become 2 here. Okay, and the output that would be written would be is comma 2, right? Finally, for others also it will happen like edureka comma 1, then it would be class comma 1, and then finally it would be 3 comma 1, and the final output would be given on the output screen. So this is how we have written the reduce function as well. Now let's understand the main function. Okay, this is what is driving or executing your entire MapReduce program. So what we need to do is we need to define an object of the class that is called configuration. So conf is an object of the class configuration right here. So using this object, we can define the entire configuration of our word count example or any MapReduce example. Okay. Now next you define the job. Now right here we are defining the job that needs to get executed on the Hadoop cluster. To this job we need to pass on the configuration of our MapReduce program along with the name of the MapReduce program. This could be anything but under double quotes, which is nothing but the string. Finally, I'm setting the jar by class. So this is the main class that we defined on the top, that is word count.class right here. This is the main class that it defines. So we need to set this class, that is word count.class right here. So set jar by class, so we are mentioning the main class of our word count example. Next we need to set the mapper class, that is map.class right here. This was the map. So we are setting the map.class. Class is nothing but the Java extension of class file. Similarly, we are setting the reduce.class right here for the job. So what we are doing is we are setting the main class of the job right here. We are setting the mapper class of the job, and then we are setting the reduce class of the job. We are telling the Hadoop framework to use these classes while executing my MapReduce job, right? We need to set the output key class. So the output key class was text right here, because the output that was received was of the text format. Output value class was of type int writable. The input format class was text input format, okay, and the output key format was text output format as a whole, okay. Finally, right here I'm setting the input path of the input file that needs to be used by the MapReduce program. So if you can see, path argument 0. So what I'm telling the MapReduce program is I'm going to pass the arguments from the command line, and the very first argument is the input path. Similarly goes with the output path right here, argument 1. So let me tell you what is this argument 0 and argument 1. So while executing the word count example, what I need to do is I'll be executing this command. So that is Hadoop jar. The name of the jar file, let's say word count.jar, and then I will be specifying the input file. Let's say it is input and the output directory is output. So this right here is nothing but the argument 0, which will be backslash input, okay, and this backslash output will be argument 1. Guys, are you clear with this? Omar says yes. What about the rest of you? Himanshu says yes. Matt says yes. Jessica says yes. Great. Himanshu says let's run the program. Sure, Himanshu. Okay, so since you are clear with this, now we'll just export the jar file. So what you need to do is right click on your project, click on export, select the jar, click next, give the name of your jar file. So what I'll do is I'll name it as word count.jar. Okay, I'll click on next, again next. Now this is a very important step in which you need to select the main class which has the main function there. Okay, so I click on OK. So word count was the main class, and then finally I click on finish. Okay, now I'll just show you the jar file that was created right here, the word count.jar. Okay, I'll open my terminal. Okay, so it's time we execute the Hadoop MapReduce program. However, before that, first we need to create the input, right? So what I'll do is I have a Python file which I showed you in the last class, using which I'm scraping the Apache Hadoop page. Okay, so I'll simply execute this desktop scrape.py and enter. It is going to scrape the entire source code of the Apache Hadoop page, and it will create a file on my desktop right here. As you can see, Hadoop Apache. Okay, I'll make the screen full. Now can anyone tell me what is the first step before executing the MapReduce program? Anyone? I hope you remember from your previous session. Put input file on the HDFS. Absolutely right, Himanshu. Correct, Umar. So I'll move the input file. I'll write Hadoop dfs-put, and then I'll give path to my input file that is present on desktop, and the name of the file was Hadoop Apache, right? And I'll put it on the root folder of Hadoop. Okay, it's time we execute our word count program. So Hadoop jar, the jar that I exported is present on my desktop, so I'll write desktop word count.jar. Next I need to mention the HDFS input file path, so it will be \Hadoop Apache. This is the file I copied, and then I need to mention the output directory that will be created on Hadoop HDFS, and let's name it as my word count, right? This is the first program that we have written on our own, and I'll press enter. So the job has been submitted and the mapper has started to execute. The mapper has finished now, and it will be the reducer which will be aggregating the results now, right? Omar says yes. And the reducer has also finished, and the job has also completed successfully. Okay, so let's go on to the name node health UI and look for the output. So the name of the directory that we created was my word count right here, as you can see in the bottom. I'll click on this. So we have the part file, and this is the word count output. As you can see, this particular term came thrice, so it is 3. So this is the entire output of the source code that was present with Apache Hadoop, right? Strong Hadoop came 4 times, right? So guys, I hope you're clear with writing a word count program or a MapReduce structure overall. Good. Now let's go back and see the next example that we'll be executing today. So MapReduce has got wide range of applications where MapReduce can be utilized. However, if we try to classify it, we can broadly classify it under 2 major applications. One could be the analytics and the second could be testing. Okay, so using MapReduce, a lot of people perform various kinds of analytics over the big data, as well as MapReduce can also be used for testing a particular MapReduce program, okay, using MRUnit. So let's move on, and to start with, we'll see examples of MapReduce on analytics, right? The very first example is MapReduce temperature example, okay? Now let's understand what it is. The problem statement of this example is we need to analyze the weather data of Austin to determine the hot and cold days that were there, okay? Now what we are doing is we are using the data set that is present at NCEI, okay, so which is nothing but National Centers for Environmental Information. Okay, so it has got huge historical weather data that is present there, and using this data we can do lot of analysis on the basis of which we can forecast the weather as well, whether the next day would be hot or it would be cold. Okay, so we can come up with certain patterns and we can analyze this data. To start with, let us go to the website and see this data set. So this is the website where you can find the entire set of weather data set from 2000 till 2016. Okay, so what we have done is we have picked one of the data set that is present from Austin. Okay, let me just show you the readme file which explains the details of this data set, okay, which will be required for you, otherwise you'll not be able to understand any of the data. So I'll quickly take you to the details of the fields that are present within the data set right here. The first field is VBAN number, the second is last date, the third is CRXVN, fourth is the longitude, fifth is the latitude, sixth is the daily maximum temperature, seventh is the daily minimum temperature. So there are many more fields right here. The fields that we are going to use in our MapReduce example would be the daily max and the daily min along with the date. Okay, so what we are trying to find out is whether a particular day at Austin was cold or whether it was hot. Okay, so now I'll quickly give you a glimpse of the data set as well. So guys, this is how your data set will look like, right? So now I hope you can understand the importance of reading the readme file. Guys, did you understand it? Good. So right here, the fields that are important to us is the date, the second column, and then the sixth column, which is nothing but the max temperature, and the seventh column, which is the minimum temperature. Okay, let me just take you back to the presentation so that we can understand it easily. As you can see right here, the sixth column represents the maximum temperature on that particular date, and the seventh column represents the minimum temperature on that particular date. Using this, we are going to calculate whether we can classify a particular day as cold or hot in Austin. Okay, interesting guys, right? It's good, right? Good, thanks. Now let's move on and see the MapReduce program that we've written to find out the cold and hot days in Austin, right? So this is the MapReduce program that we have written to find out the hot and cold days in Austin, right? I'll open up the maxmin Java file. So the very first thing is we have all the packages that we need to import just like we did in the word count example. The next is the main class, which is myMaxMin. We have the mapper class, that is maxmin temperature mapper. We have the reducer class, that is maxmin temperature reducer, and then finally the main function, which has all the job properties, right? So I'll quickly take you through the mapper logic. So what we are doing is the very first thing we have defined is int missing 9999. So this is a value which is present within the data set, which is nothing but an inconsistent data. So we will be taking care of this in the program itself. The very first thing is we are converting the value to string and storing in a line. Then if the line is not equals to 0, that is if there is a value in the line, we'll come here and we'll pick up the substring 6 and 14. So why are we picking 6 and 14? It is because from character 6 till 14 is the date of that particular day. Okay, so I'll quickly show you the data set right now so that we can understand it better. So I'll go to data sets, and this is the data set that I'm looking at. So this is the input file. Okay, so if we see, this is the sixth character from the left, right? So this is 1, 2, 3, 4, 5 and 6. So after the sixth character starts the date of that particular day and it ends at 14. Okay, as you can see, this is 7, 8, 9, 10, 11, 12, 13 and 14, right? So this is why what we have done is we are picking up the string from 6 till 14 and storing it within the date variable. Guys, are you clear with this? Can you give me a quick confirmation on the chat window? Omar says yes. Matt says yes. Good. Himanshu says understood. Great. Next, what we are doing is we are picking up the max temperature from substring 39 to 45, right? So max temperature can always be a decimal value, and that is why we are converting it into float. Similarly, we are picking up the minimum value from character 47 to 53. Once we have it, so what we are doing is, if the max temperature is greater than 35, we are classifying it as a hot day, and if the minimum temperature is less than 10, we are classifying that day as a cold day. Okay, so let's go back to the terminal and execute this. So before we go and execute, let me just quickly show you the driver class. I am sure that you are pretty much clear with the driver class already. So what we are doing is, we're defining the configuration. We are defining a job and passing on the configuration and name of the example. Okay. We're setting up the main class. We're setting up the output key class, output value class. We are setting up the mapper class, then the reducer class, and so on. Okay. Setting up the input path and the output path. So it's time we export the jar and execute the program. So I'll click on export, jar, next. I'll rename the file. So this would be hot and cold. Okay. I'll click next. Next. I need to select the main class. So it would be my max min, and finish. Let me show you the jar file. So this is the hot and cold jar. Now let's move the dataset that we have into the Hadoop distributed file system. So it's Hadoop DFS -put. I'll give the path to my datasets. It's desktop, dataset folder, and within that I'll find my weather dataset. And I'll move it to the root directory of Hadoop, and I'll press enter. Okay, it is copied now. I'll execute the weather example right away. Hadoop jar, and the jar file is present on the desktop. So I'll write desktop hot and cold.jar, right? Next, I need to mention the name of my input file, that is weather underscore dataset, which is present on HDFS. And finally, I'll mention the name of the output file. So let's name it as my weather. Okay, and I'll press enter. The mapper has finished. Even the reducer has finished now, and the job has also executed. Let's quickly go and check out the output. Let's browse the file system, which is nothing but the HDFS file system, and look for my weather right here. I'll click on that. Let's see the output. So as you can see, each day is classified as cold day or hot day, and against that you have the temperature value written. So 1.1, it was a cold day. Again, this was a cold day. So you'll see most of the values are of cold days, except the last value that is there, which is a hot day with 69.6, right? It is because this data set belongs to Austin, okay? So which is supposed to be a cold place, correct? So guys, are you clear with this? Can we go back to the presentation? Matt says right. Umar says sure. Thank you. Now we come to our next example, that is last.fm example. Okay, so last.fm is nothing but a music company which provides songs to the subscribers, okay, to the users. At last.fm you can go and listen to several songs. Okay, now in this, what last.fm does is, it has data for every user or every song that is played. Okay, this is how the data is stored. We have user ID, we have track ID. Track ID is nothing but the song ID. We have shared. Shared means that whether this song was shared or not. So if 1 is there, it was shared. 0 is there, it means it was not shared. Radio, it was listened on radio or not. So if the value is 1, it means it was. If the value is 0, it wasn't. Similarly, we come on to skip. If the value is 0, the song was not skipped. However, if the value is 1, the song was skipped. Okay, so this is how the data is stored at last.fm. So just imagine, every song that is played by n number of users n number of times, or it is shared or skipped, every detail gets recorded at last.fm. Okay, so we are going to analyze that. So there could be n number of analysis that could be done over this data. However, in this particular session, we will try to find out the unique users for every track ID. So essentially what we are trying to find out is the popularity of a particular song. So if we have multiple unique users for a particular song and the number is high, that means the song has picked up very well, right? Guys, did you understand the problem statement? Can you write down on the chat window? Himanshu says yes. Matt says it's good. Now let's go to the VM to understand the MapReduce program to find out the unique users for a particular track ID or for a particular song, right? So this is the MapReduce program that has been written to find out the unique users for every song that is there at last.fm. Okay. So right here, this is the data set. I'll quickly open it. So this is how last.fm stores its data, right? We have the user ID, we have the track ID, whether this track was shared or not, whether this track was heard at radio or not, and finally whether this track was skipped or not. Okay. So let's quickly go back to the code. Again, we have imported all the packages right here, as you can see. Okay. We have a main class that is called unique listeners. Okay. This is what we are essentially trying to find out. So we have defined a class that is called last.fm constant. It contains nothing but a list of constants using which we'll try to traverse through every record. But before moving on, let me quickly show you the significance of these constants that we are declaring. For that, I'll go to the data set and I'll copy one record, okay? So if you see, the pipe is the delimiter right here, right? Every value is separated by the pipe. The first value is the user ID, or you can say the zeroth value, correct? That is why user ID has a value 0. The second ID is the track ID or index 1, right? So track ID has a value 1. Similarly, the shared has got the index 2. Next is the radio, has got index 3, and skipped has index 4. So this is nothing but defining the index and what kind of value you are going to find on the index, right? So at times index gets confusing, and hence what we are doing is we are defining constant. So we'll find user ID at index 0, we'll find track ID at index 1, we'll find shared at index 2, and so on. Guys, are you clear with this? It's a very simple concept. Okay, great, thank you. We'll move on. So this is our mapper class, as you can see right here, in which I'm defining a variable track ID, user ID, because this is the final output that I would like to give from my mapper function, correct? So what we are doing is we are splitting the string or the input value on the basis of pipe, right? Because it was the delimiter. And then again, we are picking up the track ID and the user ID and finally dumping it out from the mapper function. So very simple, right? Guys, are you clear with this? What we are doing is we are dividing the input on the basis of pipe and we are picking up the track ID and the user ID. So track ID is nothing but the key and the user ID is the value. So guys, if you can give me a confirmation, great. Good. Now we move on to the unique listeners reducer. Okay, so this is the reducer logic right here. In this, what we are doing is we are creating a hash set. So let me tell you a unique property of hash set. Hash set cannot contain a duplicate value. Okay, so if you push any number of values, even though you're pushing a duplicate value into hash set, it will only keep one copy of it. Okay, so I hope now you can relate why we are using hash set. It is because we want to find out the unique users for a particular track ID or song, right? So what we are doing is we are traversing through every user ID that is there for a particular track ID, and then we are adding it to the hash set, that is user ID set. Even though this user ID iterable may have duplicate user IDs, however, since hash set cannot contain duplicates, it is going to store only one copy of every user. Okay, and then finally what we are doing is we are finding out the size of this hash set, which will give me nothing but the actual count of the number of users for a particular track ID, and finally I'm giving it as the output from the reducer. Is that clear, guys? Himanshu says absolutely right. It is to find out the unique listeners. Absolutely correct, Himanshu. Omar says yes, Matt says yes. Great. So I'll not be discussing the driver part. It is exactly the same. I'll just export the jar file from here. I'll click on export. Next, I'll name the file as last fm. Next, I'll select the main class, unique listeners, and I'll click on finish and OK. Himanshu says, from where we can find this code? Himanshu, this code will be there in your LMS. You can always download this code and execute it. Okay. Now let us go and check out the jar file. So this is the jar file that is created, that is lastfm.jar. The very first task is to move the dataset to the Hadoop cluster, right? So I'll write Hadoop dfs-put. I'll give the path to the input file, that is desktop, dataset, and then last fm underscore sample. Finally, I want to move it to the root directory of Hadoop and enter. The file has copied now. Now it's time we execute the last fm MapReduce program. So it's Hadoop jar desktop lastfm.jar. I need to mention the name of the input file, which is lastfm underscore sample. Next, I need to mention the output directory where it will store the final result. So let's name it as my last fm, right? It sounds very weird, right? Let's enter. The mapper has executed. So we have the final output written on HDFS. Let's go and check. Let's click on browse the file system. And the name of the output folder was my last fm. I'll click on that. I'll click on part file. And this is the result. Track 201 was played by 14 unique users. Track 202 was played by 16 unique users, and so on. There are many other analysis that you can do over this data set. Okay, that is something I'll leave up to you to imagine, and finally write a MapReduce program on that. In case you need help, guys, you can always reach out to me or the support team. Okay, so guys, are you clear with this? Can we move on? Great, thanks. So now we'll look into the MapReduce example for testing. Okay, in this we'll be using the MRUnit. MRUnit is nothing but a way or a framework using which you can get the advantages of JUnit on a MapReduce program. So what happens is you are basically executing unit test over a MapReduce program. Okay, in this what you do is you pass a set of inputs and you define the final output that should be received. After processing the input, if the output of the MapReduce program doesn't matches the absolute output that we mentioned earlier, in that case what happens is the logic of MapReduce program is not correct. However, if the output of the MapReduce program matches exactly with the output that was mentioned in the starting, then your MapReduce logic is absolutely right. Okay, so this is how the MRUnit works on a higher level. Are you guys clear with this? Great, thanks for the confirmation, guys. Now for implementing the MRUnit in MapReduce, there are certain drivers that can be utilized. One is the map driver for checking out the map function, the reduce driver for the reduce function, MapReduce driver, and then pipeline MapReduce driver. Okay. Now let's quickly go back to Eclipse and check out the MapReduce MRUnit program. Okay. So this is the MRUnit test example that we have prepared for you. Now there are a set of libraries that are required for running a MapReduce program. Okay, most of the libraries can be found within the Hadoop package itself, except the MRUnit jar. Okay, this is a jar that you need to explicitly download from internet. Okay, so it can easily be found on Google. You just have to download it and add to the class path of your MRUnit test program. Okay, the rest of the jar files can be found within the Hadoop package itself. Now let's go and see the MapReduce Java code for MRUnit. So again we have a list of packages in this program as well. There are two new packages that has been added, the MRUnit MapReduce and the JUnit test package, correct? Now we have a test example main class which extends the superclass that is called test case, right? So we are defining a map class which extends the mapper class. So this is the mapper logic that we'll be testing in this MRUnit program, okay, which is nothing but a word count logic itself, correct? So we are defining an object of the map driver class. So as you saw, we have got 4 different kinds of drivers that can be used with MRUnit. Map driver is the driver using which you can test a mapper job, okay, or a map class, right? So next is we need to define the setup function within which we are creating an object of map test, which is nothing but the mapper class that we defined, right? We are also passing the mapper object to the map driver class, correct? So what we are doing is map driver dot new map driver, and we are passing the object of my mapper class, that is map test. Finally, we have defined a test case which goes with an annotation that is @test. So the test case is test mapper, within which we are defining the input and the output values, okay? As I said, we need to specify a certain input as well as we need to specify a certain output so that the output of the mapper can be matched with the output that is mentioned with the map driver, right? So right here we are setting up the input value is 1 comma Sunday comma Avnish comma holiday. Since the logic, the mapper logic is nothing but of the word count, so what we are trying to find out is we are trying to find out the occurrences of a particular word in the input file or the input line, right? So we are trying to set up the output and we'll check whether the occurrences of this particular word, that is Sunday, is 2 or not. Okay, let's try and execute. Guys, can you predict the answer whether this test case will pass or fail before we actually execute it? Himanshu says wrong. He says it will fail. What about you, Matt? Do you think he's right? Umar, do you think he's right? You can say anything. Matt says he's right. Okay, let me just execute this for you. I'll right click, I'll click on run as and click on JUnit test. Okay, so it's executing now. Okay, as you can see, it has failed. Okay, and just read the message right here. Missing expected output Sunday comma 2 at position 0, received unexpected output, that is Sunday comma 1. Okay, so what happened is the output from the mapper function was Sunday comma 1. However, the absolute output that you mentioned in the program was Sunday comma 2, right here. I'll quickly show you. So you were telling the program that the expected output is Sunday comma 2. However, the MapReduce logic sent back Sunday comma 1. So the problem is not with the logic. It actually gave you the right answer, that is Sunday only came once. However, the result that you were checking was not correct, right? So I'll make it 1. So Sunday should only come once, right? We'll execute the program once again. We click on run as JUnit. So it's executing now. So failure 0 and we have a green signal, right? That means the unit test got executed very smoothly. It was absolutely right. The program gave the right answer. Okay? You can add as many test cases as you want. This is one test case for you to understand. So I hope you guys enjoyed this example. Can you please write down on the chat window? Himanshu says very nice example. He enjoyed it. Great. Matt says it was good. Thank you, Matt. I hope everyone else was fine. Matt says thanks for showing some real-time examples, Vinny. It was a wonderful experience. Great. There are much more examples that are there in your LMS. As well as Matt, what I suggest is you should download open source data sets like you saw the weather data set. Use it and come up with your own problem statement and finally implement the MapReduce example. I'll be there to help you out if in case you are stuck anywhere. Okay? So let's get back to the presentation now. So this is the end of today's session, guys. Before we end the session, guys, I just want to reiterate, you have a set of blocks that are there for you to learn more things and enhance your learning. So we have a set of Hadoop tutorial series that you can go through, as well as there's a MapReduce tutorial written specifically on MapReduce. So guys, please go through that and let me know in case you need any help. Okay? So if you have any queries now guys, you have the time, please ask me. I'll try and answer them. Any other query if you have? Umar says all the questions are answered. Great. Even though guys, if you have any more queries, you can certainly ask me or take the help of Edureka's support team. Okay. Also guys, there are set of assignments on MapReduce. There are around 5 to 6 assignments on MapReduce. This is a very important topic. Please go through that, attempt the assignments, and we'll discuss those assignments in the next session. Thank you everyone and have a nice day.
I hope you enjoyed listening to this video. Please be kind enough to like it, and you can comment any of your doubts and queries and we will reply to them at the earliest. Do look out for more videos in our playlist and subscribe to our Edureka channel to learn more. Happy learning!